So I'm here at Charlie Olson's shop. This is Charlie does a lot of, or all of our machine work, and I want to go over some of the stuff. We're working on my customer's car with the 330. So here we go. So this is the crank that goes with the 330, the blue one that I'm working on. I love these cranks because people don't. I mean, these things are billet steel. They're billet steel cranks, which that's why. You know, in a way, why do we spend more money on Ferrari engines is because there's some stuff that you never see, but these crankshafts are beautiful. I mean, they're billet steel. They were cut out of a solid block of steel. You know, when you look at American, you know, they don't need as much, but they're cast steel.
Cast iron or
cast steel. And so that design can make it less strong, but if it was one piece of steel that was cast and then it was cut, it makes it a lot stronger. So, well, you were going to show the difference between this one, a block, one that's done, and then what we're doing right now.
All plugs get taken out.
Yeah.
Okay, and there's a lot of them. I think
So those are all the lead plugs that basically seal all
So this is what it looks like when they're in.
Yeah,
and that's an untouched crank.
Right. Because oil goes through the mains, pressurizes it, and goes through and comes out. Yeah. And then that's the film of oil that people talk about that runs through. But because of the way it's drilled, right, these plugs...
It's the only way you can clean the crank correctly.
Or manufacturing, right? I mean, these things are drilled, and that's how they manufacture.
That's how they drill from here down into the main.
Right.
You know, it comes right through at this angle.
Right, so when you look at how it goes, they're all drilled and angled and all the way through.
It comes through and getting... This went through a Magnaflux and vibratory finish.
Right. So the rods are the same thing, shot peened, and then what's the finish on these guys?
It's a vibratory finish also.
Right.
And from what I understand, it's about a 12-hour process. Mm-hmm. And, you know, then they get rebuilt after that.
Right.
You know, same with, you know, the crank gets cleaned after it comes back from the vibratory finish.
So new bushings.
Yes.
And then, you know, the
big ends get sized.
The big ends get sized, right? And then everything gets checked again. And then, you know, and each one of these are put together, obviously numbered. So what we have is, so you could just see here, that's a 7. And then, you know, and each one of these, they have to face a certain way. So when Charlie sends this back to me, then as I'm putting it together, I'm looking to see that everything goes to the correct rod journal that it belongs to.
Yeah. And usually in sizing the big end of the rod, that's why I like to have the crank done and set. I'll put the bearings in the rod and check bearing clearance. And then I have a slight amount that I can adjust on the rod if necessary to get the clearance where we want it.
Right. And then the other thing is also just weight-wise, you're checking just...
I balance them all.
Right, so we check everything. You check the weight on all of them, and then you
surprisingly, they have a weight number on them.
Mm-hmm. Yeah, I remember seeing where they were.
But there's a weight number on them, and they're all very close, but that's just the mass weight.
Yeah, they're not checked on the balance.
End.
Right. So then when you put them on your machine to check the balance end to end, then you're taking a little bit of weight and that changes the whole balance of it. But then you try to then you have to go back. I mean, if you take a lot, then don't you have to rebalance them?
Well, first you'll start, let's say, taking all the small ends of the rod.
Right.
And whichever one's the lightest, then you'll match all the other rods to that.
Right.
Then you can go to the big end, or vice versa. But
right. And then when you're finished with all that, you're back to a new weight, but they're all the same, back to the same. But now they're done end to end.
Right.
Let's go look at the block.
Yeah. So all the sleeves come out, and this got vapor honed. Mostly, I did vapor honing just on the water passages. When I had all the sleeves out, then we had access to everything, got rid of all the corrosion inside, and that was why I primed over it.
Right.
These used to be steel cup plugs, and I made a threaded plug that I put in with a copper washer.
Great.
So it gets machined, threaded. That was never done before.
Right. So we should probably talk about liners. So liners are interesting because on a Ferrari engine, they stick out. You can feel it. They stick out like by 2 thousandths or so, right? Or 2 to 4, right? And what's interesting about Ferrari engines, and I've had this happen, people who don't do them, I've had engines where people just thought that they just deck it flat. I mean, because they're used to working on V8s, and I tell people all the time, it's like, there are people who build engines, and they might be the best V8 engine builder there is, but if they haven't done one of these, they might not know how, or just don't know. And so they're used to decking these things flat. Well, the 2000s or 2 to 4000s doesn't sound like a lot, but theoretically, what the idea of it is that as the engine gets hot, the aluminum is going to expand and contract differently than steel. So
and these particular liners, 3 inches down is where they seat in the block.
right.
So the aluminum will expand up. I bet you, when it's warm there.
Right. So that's the whole point of having this.
Right. If
this
you start out at
protrusion.
0,
The second the
go-
block grows, you're going to blow the head gasket, and that's what ends up happening. Now you can get away with it. I know there are engines out there. Trust me, I know there are engines out there that are decked flat, and whatever magic goop they sealed this thing with, it's holding.
Well,
but I do know that the whole reason why this protrusion is because the aluminum actually grows. It grows by the 2 to 3 to 4 thousandths, and the gasket is supposed to be able to handle that amount of contraction. But at the same time, it's the same thing for a machinist, right? You're making sure that these liners are the same all the way across.
And they have to be.
Right.
This one can't be 2 and this one 4.
Right.
They have to all be 2 or they're 3 or 4. They all have to be the same. So.
And obviously, you can't deck the block with the liners in place.
Right.
So what has to happen is liners come out. So this is the difference on engines that are being built, right? Some people, now liners, 40, 50, 60-year-old engines, depending on how much coolant is in there, the inside of the liners can get corrosion on them. So, your job is to figure out, can we save the liner? Can we not save the liner? Also, how much, because you can bore a liner out, or if it's gone too many times. Because one of the things that we've started to realize is some of these engines have been rebuilt so many times, they've bored to within an inch of their lives, so to speak, that you just can't save the liner. Right, so you just replace liners. So there's a lot of decisions on the machine shop and the builder and how we're going to build these cars, how we're doing it. Are we going to replace everything, or are we checking the liners and then decking the block and then get everything nice and flat?
Yep.
And then the liners have to go back in. They might not go back in perfect. I mean, you mark them to obviously each spigot, but you've got to check it again.
They all get pulled into place, and then I deck it again.
Right, then deck it again to get that height.
That's how, and I'll check around all the corners.
Because you can shim the liner up from the bottom more. You can do.
You have to make a shim.
Right, you have to make a shim.
Do that.
Right. But at the same time, I mean, the most important thing obviously is the very end product, which is that you have the same deck height, and then you have the same liner height.
And what happens with these over the years from, just seasoning, getting hot, getting cold, nothing is ever perfectly flat.
Right.
So you have to start out with a flat surface here before you can get your protrusion correct.
Sure.
So
yeah. So
in my mind, it's pretty much like one of the only ways to do it. I've seen shops with CNC machines, and they'll just go around, set up a program, and just CNC machine around every liner.
Wow. But you're paying for that Haas machine to do that. Well, that's the thing. It's like when you think about it, it's like, that you could do it. You can use technology to do that, but who do you think's paying for that amount of programming and that amount of...
Probably more importantly is that I've seen a lot of these where I pull the liners out, and they're literally packed up with corrosion in between the liners, and you can't flow any water around those liners anymore.
Right. Yeah.
They have this much room.
Yeah.
But this aluminum
is
only about that thick, and there's opening so that water can flow completely around the sleeve.
Yeah.
This particular block, even though it never had any obvious big engine failures or anything, the line bore, the first 4 main caps, were 3 thousandths tighter than the spec. So the cap must have embedded into things move.
Right.
Same kind of thing. So I checked before I did anything with the line bore, those ones that were 3 thousandths tight, just to see what kind of clearance we had, and it had 0. So if you would have taken this block and put new bearings in, the crank wouldn't have turned.
Right.
Where when it came apart, I'm sure it turned freely.
And that's the thing. It's like when I was, Francois and I had the big, bar that would check everything, and then we would slap it. And that's what that's what you have. That's basically what that does, is that aligns, and you're honing, you're making sure that that's dead straight to the center line of the block. And, You know, I'm not trying to say that people don't do it today, but I remember in the, you know, like when I first started doing this, there were people that didn't do that, and they wouldn't check it, and you'd put it in, and you wouldn't have oil pressure. I mean, all the oil pressure on this is based on that align bore, really. I mean, there's a lot of places for you to lose oil pressure, but if you don't, the main oil galleries, that first place it goes is the main bearings. So if you don't have that, it's like trying to save water in a sinking boat. It's like the water.
Too many internal leaks.
Yeah. So then, if you're losing pressure at that, or it's too tight, or you know all that stuff, the rest of the engine is not going to get oil. And the last bit of oil is the stuff that goes to the top to the valves and splashing up to the top of the head.
To your rockers.
Right. So when you lose all that oil pressure down below, I mean, we always talk about oil pressure, but it starts with the main bearing. And so that's why, like, you know, you can see what is involved with checking it and then re-honing it, boring it, and then honing it and everything like that, get it nice and tight. The other thing is, the head studs go in, and that goes.
Then it goes into the home with a plate on it.
Yeah.
Deck plate. I have them over there.
Yeah. Yeah. But the deck plate is really just so that you can secure it.
Simulates the head being on.
Right, and then it torque, because again, as crazy as it sounds, as you torque all this stuff, the aluminum and the steel, everything kind of moves a little bit. So under pressure, when you're torquing everything down, it can distort just slightly. Right. And so when you're the next step on this is the hone, right? Yep. So what you're going to do is we've set to what the pistons are going to be, and then you're going to hone it. But you want to torque the head down as it simulate the head is there, right? And then you're going to do that.
And all the main caps are torqued in place.
Right.
You know, that's why you take care of the mains first.
Right.
So.
Right. And then as this engine, as you can see, so that's the most important thing is the serial number. This is all that, and you know that's why you do all this work to save this block and have it live another day. And then these are the heads, right?
Yep.
Yeah.
And, so. That's all a rocker.
So these are also vapor honed too, right? Or how do I?
No,
these are just ultrasonic. Okay.
Yeah. I have the heads are all new guides are in and honed.
Yeah.
And these seats will be going in. I had seats made.
Okay.
You know, and all of the counterboards are cut and ready to go in.
Right.
Okay. It was just. I was waiting a while for the valves, which I got now.
Right, and then this gets cleaned again, or that's
that hasn't been cut yet.
A quick cut, right?
Right.
Now, how do these seats go? You freeze them and then drop them in, or what do you do?
Yeah, I'll heat up the head.
Heat up the head. Yep. Okay.
And
whoops, I'm just reaching here. Just show this is basically the
how
old.
I get the old guides out.
Yeah, and this is probably the original guide material. This stuff.
Yeah.
Because what I always tell people, like Ferrari engines, the original ones, you don't see a lot of them anymore. I mean, we probably still do, but the original guide material was this copper. It was a bronze, but it was a very soft material. So what ended up happening is, I mean, vintage Ferrari engines kind of get 50,000 miles before they just smoke too much.
That's all it does.
Yeah, so that's what the original guide is, and then so now these new guides are a
manganese bronze.
Manganese bronze, which is a little harder, not too hard, but hard enough. Harder.
It holds up pretty well.
And it seems to be pretty good. I mean, the nice thing about this is if these are installed correctly and done right, they should last, these could end up being 100,000 mile engines at this point, because they're not going to, and we'll put a new valve seal that's like a little Viton seal that'll slide in here.
I have those in different areas.
But what they do is they just, they'll go on the valve and seal it a lot better than the original ones. I think the original, I don't think did this one have guides on it? Or I mean, seals, or they didn't? They have the little white, or they were just open to the top. Do you remember? I can't remember on this one.
Did I think have a seal?
Yeah, I think they did. But again,
I usually, I drive them that way.
Yeah.
Because of the carbon and everything that builds up on them, so that we don't maul up the head.
But what ends up happening is these seals, even the seals that they used back in the day, you're fighting two issues. You're fighting with the material that's too soft, and then the seals that didn't last very long. So again, most Ferrari engines, again, they're now 60 some odd years old. Most of them have been rebuilt, but it depends on when the rebuild was done, because sometimes they're using NOS parts back in the 70s, and then you end up with the same problem. But since I think the last 20 years, everybody's kind of been using this material, so it's kind of standard.
Steel or the manganese bronze.
Yeah, that's been what's been available. So that's that. And then the next step is, all the rockers. So what they have to do is we got to go through and check the rollers and bushings and all that other stuff. And
we're waiting for those components.
yeah. So all that has to be done and checked and sized and put back in. And then you have the tool to check the align, because the other thing, talk about crankshaft align bore, we're also checking to make sure that the camshaft also has a.
Well, actually, I'll torque the head onto the block. And run it through.
Right.
And so the head gaskets came too.
Okay, and those are the Australian gaskets. Yeah. No, these things are the ones I say. In fact, we should probably show real quick why I like them. I don't know if you have any. You don't have any old gaskets, do you?
I think I might.
You might.
And
these are done by my friend Murray in Australia, and these things, I tell you, I really like them. I mean, I'm
gonna go get one.
They have this. They have this silicone seal that goes all the way around each stud, and the fire ring, and it's compressible. These gaskets that are available now generally, they do have a silicone seal, but they're just not nearly as nice as these. And what ends up happening here, let me show you on the block what happens, is that on the block, the water passages are basically, you can almost see them highlighted in red. So the water goes through and up, and then you have head studs here that if there's water that's in between or it gets between this section, it'll weep into the head stud. And what'll happen is, because you have a steel head stud and then you have an aluminum block and coolant that goes in there, and sometimes coolant degrades and it'll just start to seize the head on there. A lot of times when you first disassemble this block, and if you look back, when I first took this engine apart, I had a head puller that is a plate that will slowly pull this thing up, because this head is stuck to these studs because of the corrosion. So what you're trying to do, you're doing two things. One is you're trying to seal this head from the water passage to keep from blowing head gaskets, and then the other thing you're trying to do is not have the water get in there and corrode.
Water can actually if it gets around the stud, it can migrate up and go right through the nut. And water in the oil.
Yeah, you could do that too in a really bad case. So these are just solid one piece. So you can imagine, so you put this gasket in and then you torque it down. The only thing that's really sealing the water passage in here is just the fiber material or the crush of it all.
Well, you hope that this crushes at least 4,000 so that this material touches.
Right. But now think about it. So you're crushing, we talked about this 4,000 protrusion. So that is already pushing this. So this has to make up more, because it should be thicker, but you can't, because the block is asking for it to be in this recess because the fire ring has been crushed. So there's a lot going on something without much clearance. And then as the block grows and shrinks and grows and shrinks, you can have, and that I believe is probably part of it. It's almost like pumping water, because it's a block.
You'll see them leak when it's cold.
Right.
And then once it warms up, it'll stop leaking.
Right, because it's swelled up. So what's neat about Murray's head gaskets is that he's designed it to have a silicone seal through it all. Now, is this the secret sauce? Who knows? But you know what? I don't have problems with these head gaskets. They're made to follow every single passage around with the silicone seal. So it just, putting it in, and we don't have any problems. We've had a run of problems on about 10 years ago with gaskets that people put in, and they just can't seem to seal. In fact, I get an email at least once every couple months from somebody building one of these engines from somewhere in the world, and they say, I've got a problem, and they start talking about coolant issues, and I was like, which gaskets to use? And I said, did you use these gaskets? And they'll be like, why? It's like, well, there's your problem right there. So I mean, I'm not trying to say that that's the end all, but the thing is, they're obviously selling a ton of those gaskets and people are getting away with it. But if you have one little marginal issue, whether this is a little less proud, or this is not dead flat, or the torque, or one valve or one stud could be pulling a little bit, you could have all it takes is one tiny little thing. As they say, like that Swiss cheese disaster. It's like that in order to have a disaster, all the lines, all the things that line up, well, that's what happens. And so my feeling is always ensure a little bit. Are we going to have a leak-free engine by using those gaskets? No guarantees in life. We try the best we can, but if you know what the problems are, then try to buy the stuff that you will limit those amount of issues.
So then the difference between later Ferrari blocks, let's say. So here's a liner from a 330, and this is how far down.
Right.
Now, this is where it seals,
Right.
the liner. Then you take like a 308, one of these, and these seal right here.
Oh, okay.
So now this thing moves with the block,
Right.
even though this particular setup still has a little bit of,
But they still have a little bit of protrusion, or they don't?
yeah,
The 308s
these two, well, most of the ones I've seen don't.
Oh, okay. Huh.
They're flush.
Okay. But they're a slightly different design because of the way that the hi-hat sits in the, or the
Their
whatever,
depth is,
based on the
right?
top of the
Yeah,
block.
top of the deck, yeah.
Right. So that's why it's slightly different. So with the liners out, there's really not, all this is water passages. So they all go through all this, and that all has to be cleaned out. And
Just when I was taking all the liners out, I was actually vacuuming out all the corrosion that was in there.
Yeah.
Because it was just everywhere.
Yeah. No, we're changing the way we do it. I mean, in the old days when I was first learning this stuff, my mentor wasn't doing as much of it because he said they didn't have. But I was like, that's when these engines were only like 10 years old.
Right.
Now all of a sudden you get these engines, and number one, they don't drive them. So then on top of the fact that they're 40 and 50 years old, some of these engines would just sit in someone's collection for years and not start. Well, all this corrosion is just from just coolant sitting there and electrolytically corroding and dissipating, precipitating that stuff in there.
50 years ago, I think people drove these daily.
They probably did, so that's kind of what it is. Okay, well, great. Well, thanks a lot, Charlie, and I'm going to start working on my end, and with all these parts will start converging. So thanks a lot.
Okay.
Okay.